Hello everyone. Now I am going to discuss about grammars. Grammar consists of four tuples like sigma, v, s and p. Where sigma is a finite non-empty set of terminals, v is a finite non-empty set of non-terminals, S is a stack symbol that is an element of V, and P is in production. There will be four types of grammars like type 0, type 1, type 2 and type 3 grammar. Type 0 is an unrestricted grammar. It is in the form of alpha derives beta, where alpha and beta is an element of sigma uv the whole star. Type 1 is a context sensitive grammar. It is in the form of alpha derives beta, where modulus of alpha less than or equal to modulus of beta. Type 2 is a context free grammar. It's in the form of alpha derives beta, where modulus of alpha is equal to 1. That is, alpha is a single non-terminal in the left hand side. Type 3 is a right linear or regular grammar. It's in the one of the following format. That is, a single non-terminal derives a terminal followed by a single non-terminal, or it derives a single non-terminal, or it derives a epsilon. There will be two types of derivations like leftmost derivation and rightmost derivation. Let us consider this example. In leftmost derivation, we have to replace the leftmost non-terminal with its production given and continue this procedure until we get a valid string. This is the corresponding parse tree for this leftmost derivation. For this example, I derived a two leftmost derivation, which in turn says that it is an ambiguous grammar. This is the rightmost derivation for this example given. In this rightmost derivation, have to replace the rightmost non-terminal with its production given, and this is a corresponding parse tree for this rightmost derivation. A grammar which has more than one parse tree or equivalently more than one leftmost derivation or more than one rightmost derivation is called ambiguous grammar. While simplifying the grammar, we have three steps like eliminating useless symbols, eliminating epsilon productions and eliminating unit productions. There will be two types of normal forms like Chomsky normal form and Greibach normal form. Consider this example. In this example, I am going to simplify this grammar and then I am going to convert it into a Chomsky normal format. While simplifying the grammar, first we have to eliminate the epsilon production. For that, we have to find out the set of nullable variables. In this example, a nullable variable is nothing but A. After eliminating the epsilon production, the productions will be like this. The next step is to eliminate the unit production. Unit production in this production is S derives B. For eliminating unit production, we have to replace the S derives B production with the production of B. After eliminating the unit production, the result will be like this. The next step is to eliminate the useless and non-reachable symbols. In this example, there is no useless and no non-reachable symbols. After eliminating all the unwanted symbols, the simplified grammar will be like this. After simplifying a grammar, we have to convert it into a Chomsky normal form. For that, the first step is to write the productions which are already in the Chomsky normal format. This is a production which is already in the Chomsky normal form. And the next step is to replace the terminals in the right hand side productions. For that, we have to replace A with CA and B with CB. The next step is to reduce the number of non-terminals in the right hand side productions. For that, we have to replace CBA with D1 and CACB with D2. The final productions in the Chomsky normal format is this. CNF form is nothing but a single non-terminal can derive two non-terminals, or a single non-terminal can derive a single terminal. After converting into a CNF format, we have to convert it into a GNF format. GNF format is nothing but a single non-terminal derives a single terminal followed by any number of non-terminals. In the first step, we are going to check it out. The rightmost value is greater than the leftmost value. If it is not, we have to substitute the value of A to here. And here there will be a possibility of occurrence of left recursion problem. Left recursion is nothing but as non-terminal immediately derives the same non-terminal in the right hand side. In this problem, here we are deriving a new production called B3. Now A3 is in the form of GNF format. Now we have to substitute the production of A3 here, and then we have to substitute the production of A2 here. After that we have to substitute the productions of A1 here. Now all the productions are in the GNF format, that is, a single non-terminal derives a single terminal followed by any number of non-terminals. This is called Greibach normal format form.